Hello, this is Mrs. Workman. Solve x squared plus 9 equals negative 6x by graphing. X squared plus 9 equals negative 6x is a quadratic equation. The strategy we're going to use is we're going to look at the graph of its related quadratic function, because we remember that the x-intercept or x-intercepts of a quadratic function are also the solutions of its related quadratic equation. Now, let's get started on that, and it'll become a little bit clearer as we work through. So our equation is x squared plus 9 equals negative 6x. And the first thing we want to do is add 6x to both sides. So we have all the terms set equal to 0. This enables me now to rewrite it as its related quadratic function. And it looks like this. F of x is equal to x squared plus 6x plus 9. We're going to graph this function. We're going to graph this function by selecting values of x. I've selected negative 5, negative 4, negative 3, negative 2, and negative 1. We'll find the corresponding y values or f of x values, and that will give us ordered pairs, which we'll then plot on the given grid. So let's start by finding f of negative 5. In other words, what's the y value when the x value is negative 5? So we'll go back into the expression x squared plus 6x plus 9. And everywhere we see an x, we'll substitute in a negative 5. Doing a little bit of arithmetic. That's 25 minus 30 plus 9, or 4. So in this function, when x is negative 5, the corresponding y value, or the f of x value, is 4. Similarly, if we go through and we substitute in negative 4 for x, and then negative 3, negative 2, and negative 1, we would get these values. When x is negative 4, y is 1. When x is negative 3, y is 0. When x is negative 2, y is 1, or f of x is 1. And when x is negative 1, f of negative 1 is 4. So now we have those ordered pairs. It would look like that. Let's plot these ordered pairs. Negative 5, 4. 1, 2, 3, 4. Negative 5. 4 is here. Negative 4, 1 would be here. Negative 3, 0 right on the x-axis. Negative 2, 1. And negative 1, 4. Now we've plotted the points. We want to connect them with the smooth curve. We know that the graph of a quadratic function is a parabola, so these points are going to lie on a parabola. That looks like this. Now, when we started this strategy, I remembered that the x-intercepts of a quadratic function are the solutions to the related quadratic equation. So I'm looking at this point right here, negative 3, 0. It is the only x-intercept for this parabola. And so that tells me that this quadratic equation has one solution, and that is x is equal to -3. Now if we want, just to feel a little bit more comfortable, let's put the original equation, x squared plus 9 equals -6x right here. And we believe that x equals -3 is a solution. So let's see if that value of x satisfies the given quadratic equation. So I'm going back through, and everywhere I see an x, I'm going to substitute in a -3. -3, the quantity squared is 9, and 9 plus 9 is 18. A -6 times a -3 is 18. There we have our check. The solution to the given quadratic equation is x equals -3, and we found it by graphing.